So, we are still talking about radicals, and what we're doing with them today is rationalizing denominators of radical expressions. So, let me try and explain what that means. When we talk about rationalizing the denominator, of course, a denominator is the bottom part of a fractional expression, and rationalizing the denominator means that we want the denominator to not have any radicals, square roots or cube roots or anything like that in it. So rationalizing the denominator means to rewrite a fractional expression so that it does not have a radical sign in the denominator. For example, 1 over the square root of 2 does have a radical sign in the denominator, but we can multiply the top and the bottom by square root of 2. Remember, with any fraction, we're allowed to multiply the numerator and denominator both by the same thing, and that keeps it equivalent. So if we multiply by the square root of 2 on top and on the bottom, what we get is, on the top we have 1 times the square root of 2, which is the square root of 2. And on the bottom we have the square root of 2 times the square root of 2, which is 2. Two ways of thinking about what's happening there. You can think, okay, we've got the square root of 2 times 2, that's the square root of 4, which is 2. Or the other way to think about what's happening there is that when you take the square root of 2 times itself, you have the square root of 2 squared. Squaring undoes the square root and leaves you with just 2. So now let's work through some more examples where we are rationalizing the denominator. The square root of 13 over the square root of 3. To rationalize this denominator, we're going to have to multiply it by another square root of 3. That way we'll have the square root of 3 squared, which will just be 3. And whatever we multiply by on the bottom, we got to multiply by the same thing on the top. So we're multiplying the top and the bottom both by the square root of 3. Then on top, we get the square root of 13 times 3, that's the square root of 39. And on the bottom, we get the square root of 3 squared is just 3. Or you can think it's the square root of 3 times 3, it's the square root of 9, but that is 3. So that's the end. We have accomplished our mission of rationalizing the denominator. Let's try another one, 12 over the square root of 3. Remember what we did last time? We're doing the same thing here. We're multiplying by the square root of 3 on top and on the bottom. This time it's just a 12, not a square root of 12, but just a 12 times the square root of 3. So we have to write that as just 12 times the square root of 3. The 12 is not under a square root sign, but the 3 is. And on the bottom, again, square root of 3 times square root of 3 is 3. Now here there's one more thing we can do. The 12 on top over the 3 on the bottom, we can just divide that and get 4 times the square root of 3. So 12 times the square root of 3 divided by 3 gives us 4 times the square root of 3 for our final answer. Okay, next example, square root of 11 over the square root of 10. So what am I going to multiply by to rationalize this denominator? To turn the square root of 10 into just a nice whole number without a square root sign, I would multiply it by another square root of 10. And whatever I multiply by on the bottom, I have to multiply by the same thing on top. So I get square root of 11 over square root of 10 times square root of 10 over square root of 10. So on top, what do we have? We have the square root of 11 times 10. That's a square root of 110. And on the bottom, we have the square root of 10 times the square root of 10. You can either think that's the square root of 100, which is 10, or you can think that's the square root of 10 squared, which is 10. And there's nothing further to do here. So that's our final answer, the square root of 110 over 10. Next example, 10 over the square root of 2x. What do we have to multiply this by to rationalize the denominator? When we had the square root of 3, we multiplied by another square root of 3. When we had the square root of 10, we multiplied by another square root of 10. Here we have the square root of 2x in our denominator, so we're going to multiply by another square root of 2x on top and on the bottom. So when we do that, on top we just get 10 times the square root of 2x. The 10's not under the square root sign, the 2x is, so it just stays 10 times the square root of 2x. And on the bottom we have the square root of 2x squared, which is just 2x. Now we're almost done, but there's one more thing we can do to put this in lowest terms. Can you see what it is? The 10 on the top and the 2 on the bottom, divide out. We can divide them both by 2 and reduce this to 5 over the square root of 2x over just x. The 10 divided by 2 is 5, and the 2x divided by 2 is just x. Next example, 20 over the cube root of 2. So this time we don't have a square root, we have a cube root. What can we multiply that by to rationalize that denominator? What do you think I'm going to multiply the cube root of 2 by? Your first guess might be the cube root of 2. That's the kind of thing we were doing before, but that's not quite going to work here, because when you take the cube root of 2 times the cube root of 2, you get the cube root of 4, and that's still got a radical sign in it. That's still irrational. The cube root of 4 isn't anything special. What we need is the cube root of something that is a perfect cube, so that we can say what the cube root actually is. So can you think of how to get that to happen? We want to take 2 under the cube root sign and multiply it by something else so that we end up with the cube root of a perfect cube. You remember what numbers are perfect cubes? Well, there's 1 cubed is 1. There's 2 cubed is 8. 2 times 4 would give us 8. So if we take this cube root of 2 and multiply it by the cube root of 4, we do get the cube root of 8, which would just be 2. So we're multiplying the top and the bottom by the cube root of 4. 20 times the cube root of 4 over the cube root of 2 times the cube root of 4. The cube root of 2 times the cube root of 4 would be the cube root of 8, which is just 2. And then this 20 divided by this 2 would be 10. So we end up with 10 times the cube root of 4 for our final answer. Now here's where things get a little more complicated. What if we've got a denominator that has more than one term? It's not just the square root of something, but it's the square root of something and then maybe plus or minus something else. In that case, there's a trick. And that trick is to multiply on top and on the bottom by what's called the conjugate of the denominator. Something that's almost the same, but with a different sign in the middle. So for example, the conjugate of 2 plus the square root of 3 would be 2 minus the square root of 3. The reason that works is because of the fact that when you multiply a plus b times a minus b together, you just get a squared minus b squared. Remember, FOIL would give you a times a, and then minus ab and plus ab, but those would add up to 0, so that would cancel out, and then minus b squared. So if you want to end up with something that just involves the squares of the terms you started with, that's how to accomplish that. So the trick is when you have more than one term on the bottom, and one or possibly both has a square root, If you want to get rid of all the square roots, you would multiply by the conjugate, the same thing but with a different sign in the middle. So here, where we have a 2 plus the square root of 3 in the denominator, we would multiply by 2 minus the square root of 3, because then when you multiply that out, you get 2 squared, which is 4, minus the square root of 3 squared, which is 3. And then 4 minus 3 would just be 1. So the denominator just ends up being 1. Meanwhile, we multiplied by the same thing on the numerator that we did in the denominator. So on top we have 1 times 2 minus the square root of 3, which is just 2 minus the square root of 3. So we end up with 2 minus the square root of 3 on top over just 1 on the bottom, and then dividing by 1, well, 2 minus the square root of 3 divided by 1 is just 2 minus the square root of 3. So some more examples of that. Say we want to rationalize the denominator of 20 over 3 minus the square root of 5. Remember what I said to multiply by. So here we're going to be multiplying by the conjugate of 3 minus the square root of 5, which would be, say it really loud so I can hear you through the screen. Yes, 3 plus the square root of 5. So we multiply by that on the bottom and on the top. So here's what happens when we do that. On the top, we're taking 20 times 3 plus the square root of 5. And because of the distributive law, the 20 gets multiplied by both terms. So 20 times 3 is 60, plus 20 times the square root of 5 is 20 times the square root of 5. And on the bottom, we get 3 squared. 3 times 3 is 3 squared, or 9, minus the square root of 5 squared. Square root of 5 times square root of 5 is the square root of 5 squared, or just 5. Now, what is 9 minus 5? Well, it's just 4. So now we're looking at 60 plus 20 times the square root of 5 all over 4. And we can simplify that because the 60 and the 20 root 5 are both divisible by 4. 60 over 4 is 15, plus 20 root 5 over 4 is 5 root 5. So our final answer simplifies down to 15 plus 5 times the square root of 5. One more of these. 4 over the square root of 13 minus 5. To rationalize the denominator, what are we going to have to multiply this by? Same thing, but with a different sign in the middle. So that would be the square root of 13 plus 5. So we multiply top and the bottom both by the square root of 13 plus 5. And when we do that, what do we get? On top, we get 4 times the square root of 13 plus 4 times 5. 4 root 13 plus 20. And on the bottom, we get the square root of 13 times itself. Square root of 13 squared would just be 13, minus 5 times itself. 5 squared would be 25. So 4 root 13 plus 20 on top over 13 minus 25 on the bottom. Remember, the square root of 13 squared is 13, and 5 squared is 25. Now, what is 13 minus 25? It is negative 12. So 4 times the square root of 13 plus 20 over negative 12. And we can simplify that because the numerator and the denominator both have a common factor of 4 that we can divide out. So after we divide the numerator and the denominator both by their common factor of 4, this reduces to 1 times the square root of 13 plus 5 over negative 3. So square root of 13 plus 5 over negative 3, or since a positive divided by a negative comes out negative, we could just say that the whole thing is negative square root of 13 plus 5 over 3. Okay, that's it for that section.